the packet forwarding function is to encapsulate packets in the appropriate data link frame type for the outgoing interface, as we have explained here. Okay. So the more efficiently a router can perform this task more efficiently, so more speed with less cost, the faster packet can be forwarded by the router. So if a router receives a packet and it immediately takes the decision and forward this packet, this is very important. So in order to do packet forwarding mechanism, the router uses three mechanisms: process switching, fast switching, and Cisco Express forwarding mechanism. We will explain shortly with everyone. Process switching, what does it mean? Look here. The ingress interface, this is the router, the interfaces that enter to the router. Okay, packet 1, second packet, third, fourth packet. So an order packet forwarding mechanism still available for for Cisco routers. This one, process switching. When a packet arrives on an interface in this way, it's forwarded within the router to something called control plane. This one to the CPU of the router. Okay, and the router this use the routing table to create a match between the destination IP address and the root entries within the routing table. And then it determines for each packet the ingress interface or the outgoing interface for each route. Okay. So match with entry and then determines the exit interface and forwards the packet. So he will receive some packets, he do some comparison matching, far left bits matching. If it's okay, he will find for each packet which egress interface should forward the packet. Okay, it's important now to understand that the router does this for every packet. For every packet it does. Even if these all packets have the same destination IP, he will check for every packet the destination. And he will do this for all packets, as you see. This is what we call a process switching. So processing switching is to process, to create or to find the longest match between the destination IP address and the root entry within the routing table. Fast switching, what does it mean? Fast switching, it's almost the same, but another older packet forwarding, which was the successor to process fast switching, uses a fast switching cache to store next hop information. Next hop, only next hop. When a packet arrives on an interface, it's forwarded to the control plane where the CPU search for a match in the fast switching cache. So they're here in the routing table, right? Here, he searched in the fast forward cache. Search for a match in the fast switching cache. If it's not there, if it doesn't find the match, it means that this is the first packet that will come to this router. So if it's not there, it's a process switch and forwarding the exit interface. It will come back to here. So if it doesn't find here, then he will use this way, okay? So then the flow, when it creates a new match as this one, because it doesn't find the match within this fast forward, it creates this and then adds this information to this cache. If the same router of the same packet arrives with the same address, now the second time he will not do this way. Why? Because we added already this to the cache, so he will search the cache, and if he will search, then he will find that this is already used. Then it immediately forward the packet. So the flow information for the packet is then stored in the fast switching cache. If another packet going to the same destination arrived on the interface, the next hop information in the cache is reused without a CPU intervention. So, as I told you, next time for this packet, we don't use this CPU. The CPU will search here and find the match, then it forwards immediately this way, okay? Cisco Express forwarding, what does it mean? We use two things, FIB and adjacency table. The most recent and default Cisco iOS packet forwarding mechanism. This is more recent. Cisco routers may use this, and you know when we have configured router and show interfaces, we see something what we call CEF. So CEF builds two things. Forwarding information base is the routing table, for example, as the routing table, optimized routing table, and an adjacency table. The table entries are not packet triggered like fast switching, but it change triggered. What does it mean? Such as when something change in the network topology. So packet triggered, it means that we depend on the packet to forward, to take decisions, okay, to forward the packets. However, change triggered, we depend on the network change. So when network has converged, what does it mean converged? Converged, if we have some table, routing table, or some information about network, and there's two routers are off, so there is something has been changed. So network will converge if it becomes stable. So as we have created the stable topology of the network, okay, and adjacency table contain all the information that a router would have to consider when forwarding a packet. Example, next hop, MAC address, interface information, everything. So we will have two things here. We will have the forward information based and adjacency table. The table entries are changed triggered. This table will contain the network topology information, and when the network has converged, it means it becomes the topology becomes stable. I mean, a router now will specify a route from A to Z using this converged network topology, and FIP is the same copy. It's a copy of routing table but optimized. Okay, and adjacency table, it has the next hop information about the neighbors for a router. So FIB is optimized routing table, and adjacency table, it has information about next hop information neighbors of the router. Okay, Next, hop and information interface, for example. Basic router configuration review. What does this explains? Now, imagine that we have this topology. We have two routers, router 1, router 2, LAN 1, LAN 2, LAN 3, LAN 4, S1, S2, S3, S4, okay. And this is also connected to internet service provider here, okay? So, we will use the topology and the figure will be used for configuration and verification examples. We will use this in the exercises later on. It will also be used in the next topic to discuss the IP routing table. Look here, this is the network address /00/24, and you see this is 1, okay? It means that this is 10.0.2.1. This is 1, and this is also version 6.1 here, 1 here, okay? This is the IP addresses of this interfaces, okay? And here the same. So we have all together IP version 4, IP version 6, even for the PCs. This is the network addresses here, because it's 10.0.1.0. And this is also network address, okay? This is the address of this host. It's 10.0.2.10, and this is the this here. It's this address, 2 colons, 10. Okay. Okay. This interface IP address of the router is 10.0.1.1. This is 10.0.2.1. This is 10.0.4.1. This is 10.0.5.1. And the same for the and this router, this interface is 10.0.3.2. This interface is 10.0.3.1. Okay, this interface and this interface. Okay, and here the same. Okay, we will go here. Here it's always the same, 10.0.3. Sorry, here is no, this address. And for version 6, this address with 2. Okay? So this for this interface and this for this interface. So this is 224, and this is 226. Okay? We will see. How to configure these interfaces of R1? This R1 has 3 interfaces, D00, D01, S